Matrices VACQs. Our first question is here two matrices are given and they are equal. Then find the value of x comma y comma z and a. So first write down the given two matrices and they are equal. If two matrices are equal, their corresponding elements are equal. So what about first element of first matrix, that is x minus 3, and what about first element of second matrix, that is 5. When two matrices are equal, their corresponding elements also equal. Now equating the corresponding elements, so what about first element x minus 3 equals to 5, like that. What about second element, that is 2y minus 8 equals to 2, and third element z plus 2 equals to minus 2, and fourth one 6 equals to a minus 4, or we can write a minus 4 equals to 6. From this four equations we have to make x, y, z and a as subjects. So if you make x as a subject, here x becomes 5 minus 3 becomes plus 3, 5 plus 3, so x equals to, what about 5 plus 3 is 8, so x equals to 8. Now here 2y we can write 2 minus 8 becomes plus 8, so 2y 2 plus 8 is 10, so y equals to 10 divided by 2, 2 ones are 2 5s are, therefore y equals to 5. Next, now here if you make z as a subject, minus 2, and this plus 2 becomes minus 2, and what about minus 2 minus 2 is minus 4, therefore z equals to minus 4. Finally a minus 4 equals to 6, a equals to 6 minus 4 becomes plus 4, and 6 plus 4 is 10, therefore a equals to 10. So these are the values of x, y, z and a. Now second problem also similar like previous one. Here also two matrices are equal. If you equate the corresponding elements, you will get the values of x, y, z. So what about first element, x minus 1 equals to 1, and here 5 minus y is 3, and this one z minus 1 is 4, and last one a minus 5 is 0. From this one we have to make x comma y comma z and a as subjects. So x becomes minus 1 become plus 1, 1 plus 1 is 2, so x equals to 2, and y if you make as a subject 5 plus 3 becomes minus 3 equals to y, so y equals to 5 minus 3 is 2. And from this one z equals to, we can write 4 minus 1 become plus 1, so 4 plus 1 is how much, 5, therefore z equals to 5. And finally a, so if you make a as a subject, minus 5 becomes plus 5. So these are the values of x, y, z and a. Now third problem, a and b, two matrices are given. We have to find the value of 3b minus 2a. So first write down the given b as well as a. So we have to find 3b minus 2a, means 3 times of matrix b minus 2 times of matrix a. So first we have to multiply with 3 each and every element of matrix B. So 3 3s are 9, 3 2s are 6, 3 1s are 3, 3 1s are 3, 3 2s are 6, 3 3s are 9, minus 2 times of A. So 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 3s are 6, 2 2s are 4 and 2 1s are 2. Now subtraction of two matrix. Subtraction of two matrix means we have to subtract first element from first of B, second from second, like that. So 9 minus 2, 6 minus 4, 3 minus 6, 3 minus 6, 6 minus 4, finally 9 minus 2. So what about 9 minus 2 is 7, 6 minus 2 is 6 minus 4 is 2, 3 minus 6 is minus 3, 3 minus 6 is minus 3, 6 minus 4 is 2, and 9 minus 2 is 7. So this is our required 3b minus 2a. Now fourth problem, a and b given as well as relation between a and b given. So 2x plus a equals to b. What about 2x plus a equals to b? Then find the value of x. So first write down the given matrix A as well as B. And what about relation between A and B? 2x plus A equals to B. From this one, if you make x as a subject, we have to find the value of x. So making x as a subject, so this 2x becomes b minus a. B minus a means b, from b we have to subtract a. So what about b? 3, 8, 7, 2 minus 1, 2, 3, 4. Subtraction means from first element to first element. 3 minus 1 is 2, 8 minus 2 is 6, 7 minus 3 is 4, 2 minus 4 is minus 2. So this is the value of 2x. So finally we have to find x. X means each and every element divided by 2. If you divide b minus a by 2, so 2 by 2 is 1, 6 by 2 is 3, 4 by 2 is 2, minus 2 by 2 is minus 1. So this is our required x. Question number 5. A and B given, we have to find the values of A and B. So write down A and B. So A plus B means we have to add the corresponding elements. So first element 2 plus 1, second element 3 plus 0, third one minus 1 plus 1, fourth one 7 plus 2, next 8 minus 4, next 5 minus 1. If you simplify, 2 plus 1 is 3, 3 plus 0 is 3, minus 1 plus 1 becomes 0, 7 plus 2 is 9, 8 minus 4 is 4, and 5 minus 1 also 4. So this is our A plus B. Next, question number 6, very important. Okay, so define trace of a matrix, find the trace of given matrix. So first write down the definition. What is the definition of trace of the matrix? The trace of a square matrix. Square means number of rows equals to number of columns. Example, 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix, 1 like that. N by n matrix is called square matrix. The trace of a square matrix is the sum of elements in the principal diagonal. Every square matrix contains two diagonal. So this is called principal diagonal, and there is normal diagonal. So trace means sum of elements in the principal diagonal. So 1 minus 1 plus 1 are the elements of principal diagonal. So trace means we have to add them. So trace of A is denoted by TR of A. So first element, what about first element? That is 1 plus second element is minus 1 and third element is 1. So 1 plus 1 minus 1 get cancelled. Therefore trace of the given matrix is A1. Trace of the given matrix is 1. Our next question is, if A equals to 2 by 2 matrix I 0 0 1, then find the value of A square. So what about A square? A square means A into A. So A square, that is A into A. Here multiplication. So multiplication of two matrix, multiply rows into column. So we have to multiply first row with first column. So I into I, that is I square. I into 0 is 0. Next, I into 0, that is first row second column is 0, plus 0 into I also 0. Next, with second row, so second row first element is 0 into I is 0, plus I into 0 also 0. Finally second row second column, 0 into 0 0, plus I into I is I square. So this will become I square 0 0 and I square. So we have value of I square. What about value of I square is minus 1. In complex number, value of I square is minus 1. So this will becomes minus 1 0 0 minus 1. So if you take minus, this will become 1 0 0 1. And what about 1 0 0 1? That is identity matrix or unit matrix. So a square equals to minus I. Next question, question number 8. If a equals to 2 4 minus 1k and a square equals to 0, then find the value of k. Given a equals to 2 4 minus 1k and a square means 0 matrix, that is 0 comma 0 comma 0 0 0, 4 elements, 2 by 2 matrix. Now multiplication of a into a, that is a square, consider as 0 0 0 0. So multiply rows into column. So first row, first column. What about first row, first column? 2 2s are 4, first row, first column. 2 2s are 4, 4 1s are minus 4. Now first row, second column. 2 4s are 8, 4 into k plus 4k. Now multiply with second row. Minus 1 into 2 is minus 2, k 1s are minus k. Next, minus 1 into 4 is minus 4, plus k into k is k square. This one equals to 0 0 0 0. Now two matrices are equal, their corresponding elements also equal. Equating the corresponding elements, we will get the value of k. So if you equate this one with 0, so you will get minus 2 minus k equals to 0, or k equals to minus k become plus k, k equals to minus 2. We can equate any other element. If you equate this one with 0, so you will get k square plus 4 equals to 0, sorry, minus 4. So k square equals to plus 4, k equals to plus or minus 2. Square root of 4 is plus or minus 2. But k value minus 2 only satisfying all the condition. Therefore, we have to consider k equals to minus 2 only. So right answer is k equals to minus 2, which satisfy all the condition. If you equate this one also, you will get k equals to minus 2. Therefore, our final answer is k equals to minus 2. Now question number 9. A and B given, find the value of A plus A transpose as well as A into A transpose. What about transpose? Transpose means we have to convert rows into columns. The matrix obtained by interchanging rows into column is called transpose of a given matrix. So here A is given 2 minus 4 minus 5 3. So what about first row? That is 2 minus 4 becomes 2 minus 4. First row becomes first column of A transpose and second row becomes second column of A transpose. Now we have A as well as A transpose. First bit, A plus A transpose, addition of two matrix. Simply adding corresponding elements. So first element 2 plus first element 2, minus 4 plus minus 5. Next, minus 5 plus minus 4. And finally 3 plus 3. So 2 plus 2 is 4, minus 4 minus 5 minus 9, minus 9, 3 plus 3 is 6. So this is simply A plus A transpose. Now A into A transpose, multiplication. Multiplication always rows into column. So first row, first column, 2 2s are 4, minus into minus plus, 4 4s are 16. First row, first column. Next, first row multiply with second column. So 2 5s are minus 10 minus 4 3s are 12. Now second row, first column, minus 5 2s are minus 10, 3 4s are minus 12. Now finally second row, second column, 5 5s are minus half minus plus 25 and 3 3s are 9. So 4 plus 16 is 20. This is minus 22, minus 22, and this one is 34. Therefore, A into A transpose is 20 minus 22 minus 22 and 34. Question number 10. Define a symmetric matrix if A is a minus 1 2 3 2 5 6 3 x 7 is a symmetric matrix. Find the value of x. So first write down the definition of symmetric matrix. What is symmetric matrix? A square matrix A is said to be a symmetric matrix if A equals to A transpose or A transpose equals to A. A square matrix is said to be symmetric matrix if A transpose equals to A. So given matrix A and its transpose, how to find A transpose? Converting rows into columns, we will get A transpose. So this is our A and this one is A transpose equal. Okay, both are equal. Now equating the corresponding elements. So I am equating third row second element with third row second element. So what about x equals to 6? From equating corresponding elements, so what about x equals to 6? Okay, next question number 10. Define skew symmetric matrix if 0 comma 2 comma 1 minus 2 comma 0 comma minus 2 minus 1 comma x comma 0 is a skew symmetric matrix. Find the value of x. So first write down the definition of skew symmetric matrix. What is a skew symmetric matrix? A square matrix A is said to be skew symmetric matrix if A equals to minus of A transpose or A transpose equals to minus A. A square matrix A is said to be skew symmetric matrix if A equals to minus of A transpose. So here given A, matrix A and its transpose. So minus of its transpose. Now equating the corresponding elements. So x equals to minus of minus 2. So minus of minus plus. Therefore x equals to 2. Now next question is question number 11. If A is given and determinant of A is 45, then find the value of x. So here given determinant of a matrix is 45. So we have to find the value of x. Okay. So determinant is how much? 45. So plus minus plus. We have to find determinant. So how to find determinant? This first element, leave this first row, first column, cross multiply. So 3 into x becomes 3x minus of minus 6 4s are 24 minus 0 into something, you will get anyway 0, plus 0 into something, you will get 0, equals to 45. So 3x plus 24 equals to 45. From this one, if you make 3x as a subject, 3x becomes 45 minus 24. 45 minus 24 is 21. So 3 1s are, 3 7s are. Therefore, the value of x is 7. Now next question, find the determinant of the matrix 1 square, 2 square, 3 square, 2 square, 3 square, 4 square, 3 square, 4 square and 5 square. So what about 1 square? 1 square is 1, 2 square is 4, 3 square is 9, 4, 9, 16, 9, 16, 25. So here we have to find determinant. So we can do, big numbers are there. So little bit row operation. So R2 changes to R2 minus R1 and R3 changes to R3 minus R2. Okay. So first row is as it is, 1, 4, 9. Now 4 minus 1 is 3, 9 minus 4 is 5, 16 minus 9 is 7, 9 minus 4 is 5, 16 minus 9 is 7, 25 minus 16 is 9. Now we can find out determinant easily. So 1 times of 5 nines are 45 minus 7 sevens are 49 minus 4 times of 3 nines are 27 minus 7 fives are 35. Finally 9 times of 3 sevens are 21 minus 5 fives are 25. So here 1 times of 45 minus 49 is minus 4. Minus 4 times of 27 minus 35 is minus 8 plus 9 times of 21 minus 25 is minus 4. So 1 4s are minus 4 and I am writing first this one, 9 4s are minus 36 minus into minus 8 4s are 32. So minus 40 plus 32 is how much? Minus 8. Therefore, determinant of the given matrix is minus 8. Next question number 13. Find the adjoint and inverse of A equals to 1, 2, 3 minus 5. So here a matrix is given, its order is 2 by 2 matrix. How to find adjoint and inverse of any 2 by 2 matrix? So let us, if A equals to a 2 by 2 matrix whose elements are A, B, C, D, 2 rows and 2 columns, then first determinant of A is just we have to cross multiply, that is AD minus BC. Whatever determinant of given matrix A is AD minus BC. Now next, adjoints means we have to interchange A and D. We have to interchange A and D. In the place of A we have to write D, in the place of D we have to write A. And one more thing, sign of B and C we have to change. Sign of B and C we have to change. That is our adjoint. D minus B minus C A. Now finally A inverse equals to 1 by det A into adjoint A. Det means AD minus BC. Adjoint means D minus B minus C A. So here A inverse becomes 1 by AD minus 1 4s are minus 4 minus 3 2s are 6 AD minus 4 1 change of BC minus 2 minus 3. So minus 4 minus 10 is minus 4 minus 6 is minus 10. So if you divide by minus, so this will become 4 2 3 minus 1, or we can write 4 by 10, okay, 2 by 10, 3 by 10 and minus 1 by 10. This is our A inverse. What about adjoint? Adjoint means adjoint simply minus 4 1 minus 2 minus 3 is adjoint. Okay, got it? Next question number 14, find the rank of matrix. 3 by 3 matrix is given. So what about order of given matrix is 3 by 3. So first find out determinant of the given matrix. So that is how much? Determinant of a matrix is 0. Why 0? Two identical first row first column or second row second column, two identical. If any matrix is having two identical rows or columns, its that is two identical rows, therefore that is 0. Okay, so determinant of 3 by 3 matrix is 0. If determinant of 3 by 3 matrix is not equals to 0, then order of that matrix is 3. Determinant of 3 by 3 matrix is not equals to 0, then order of that matrix is 3. If determinant of 3 by 3 matrix equals to 0, then we have to find determinant of submatrix. Submatrix means after deleting submatrix, after deleting one row and column. If you delete first row and first column, you will get 1 1 1 1, and its determinant also 1 1s are 1 minus 1, 1 minus 1 is 0. Okay, therefore order of rank of this matrix, rank of A is 1. Given matrix is 3 by 3, that is 0, therefore we have to find determinant of submatrix, that is 2 by 2, that one also 0, then its order is 1. If the order if the determinant of 3 by 3 matrix is not equals to 0, then rank of that 3 by 3 matrix itself 3. If determinant of 2 by 2 matrix submatrix is not equals to 0, then rank is 2. So see one more problem. A is given 1 2 3 2 3 4 0 1 2. First find out determinant, that is 1 times of 3 2s are 6 minus 4 minus 2 times of 2 2s are 4 minus 0 and 3 times of 2 1s are 2 minus 0. So 6 minus 4 is 2, 2 4s are minus 8, 3 2s are 6, 6 minus 6 is 0. So determinant of 3 by 3 matrix is 0. Next, rank is not equals to 3. Next we have to find determinant of any submatrix, 2 by 2 matrix. Okay, after deleting first row and first column, it will become 3 4 1 2. 3 2s are 6 minus 4 is 2, which is not equals to 0. So determinant of 2 by 2 matrix is not equals to 0. Any one 2 by 2 matrix is not equals to 0, then its rank is 2. Therefore rank of A is 2. Okay, now next question, find the adjoint and inverse of the matrix cos alpha minus sin alpha and cos alpha. So if A is ABCD, then its A inverse is 1 by AD minus BC into D minus B minus CA, where D minus B minus CA is called adjoint and AD minus BC is called determinant. So A is given, so A inverse, that is 1 by AD cos into cos, cos square alpha, minus of minus plus, sine into sine is sine square alpha. So this is determinant. Now if we have to interchange AD, both are cos alpha, after interchanging also cos alpha only. So minus B, so sine alpha minus is there, if you multiply with minus it will become plus sine alpha and this will become minus sine alpha. So what about cos square plus sine square, that is identity 1. So 1 by 1 into cos alpha sine alpha plus sine alpha minus sine alpha cos alpha. So this is adjoint as well as inverse of the given matrix itself, since determinant is 1, so 1 by 1. Okay, now next question is construct a 3 by 2 matrix whose elements are defined by Aij equals to 1 by 2 mod I minus 3j. Okay, so what about the order of the matrix is 3 by 2, means how many rows are there? 3 rows and 2 columns. So let a matrix A having 3 rows and 2 columns. Generally we denote by A11, A12, A21, A22, A31, A32, means this element is, its position is first row first column. So in the place of I and j, so what about first element? A11, so that is 1 by 2 mod I means 1, 3 times of j also 1. So 1 minus 3 is minus 2, mod is there, plus 2, 2 by 2 is 1. So first element is 1. Next, A12 means first row second column. So value of I is 1, 3 times of value of j is 2. So 1 minus 3 2s are 6. 1 minus 6 is minus 5, mod is there, plus 5 by 2. Next, A21. So 1 by 2, value of I is now 2, 3 times of j value is 1. So 2 minus 3 is minus 1, mod is there, plus 1, 1 by 2. Next, A22, 1 by 2 mod 2 minus 3 times of 2, 3 2s are 6, 2 minus 6 minus 4, minus is there, so plus 4 by 2. And what about 4 by 2? That is 2. Next, A31, third row first column, 1 by 2 mod, now I is 3, 3 times of j is 1. So what about 3 minus 3 is 0. So our 31 element A31 is 0. And finally A32, third row second column, 1 by 2 I value is 3, 3 times of j value 2. So 1 by 2, 3 minus 3 2s are 6, 3 minus 6 is minus 3, minus 3 by 2, mod is there, plus 3 by 2. Therefore our required matrix A is, what about first element? 1, second element is 5 by 2, next 1 by 2, 2, 0, and finally 3 by 2 is our required matrix.